Alright, so this video is going to go over every question in your review packet for Test 1. Just a reminder that Test 1 is on weeks 1 through 5 of material from your workbooks, but your best study tool is this review packet. So let's get started with the first question, 193. So 193 is just asking you to simplify the following. So part A is 3x minus 5x plus 2y minus 4x. To simplify that, it's not like solving an equation, it's just simplifying, combining like terms. So I'm going to start by just circling what my like terms are. Remember, to be a like term, you must have the same variable and the same exponent. The three that I have circled all have an x and they have a 1 as an exponent, so they are like terms. To combine them, I just combine the numbers by doing those operations. Also notice that I put circles around the negatives in front of the 5 and the 4 because those are part of those numbers. So when I combine them, I do 3 plus a negative 5, which is negative 2, plus a negative 4, which is negative 6. So my answer is going to be negative 6, and the x comes down. Okay, but I am not completely done. I still have this plus 2y as part of my problem. That plus 2y comes down as well because there's nothing to combine it to, and that is my final answer. All right, next problem. I have PEMDAS. You have to simplify this by using your order of operations, which is PEMDAS. P stands for parentheses, E is exponents. Remember, multiply and divide happen in the same step, left to right, and addition and subtraction happen in the same step as well, from left to right. So for this one, I'm going to start with the P, which is parentheses. I have 5 plus 3 inside of the parentheses, which is going to get me 8, and everything else is going to come down. And now I've taken care of P, I move on to E, which is exponents. My exponent is 2, and 8 is being squared. 8 squared is going to get me 64, and again, everything else comes down. I would then look for multiplication and division, but I don't have any. Last, all I have is a subtraction. 64 minus 6 gets me 58 as my final answer. All right, moving on from simplifying to question 194. It says, given that f of x equals x over 2, remember that means x divided by 2, plus 1, evaluate the following. Evaluate just means do what the parts are telling you to do and simplify down to a single number. Okay, so when it asks me f of negative 8, notice that it's asking me from this original f of x. And now it's asking me for f of negative 8. Notice where that negative 8 is. This problem is just telling me that x is negative 8. So in that function, x divided by 2 plus 1, I have to substitute negative 8 in place of x and bring everything else down. Once you plug in that negative 8 for x, you PEMDAS it to simplify. I have to divide before I add, so negative 8 divided by 2 is a negative 4. The plus 1 comes down. And then all I have left is addition. Negative 4 plus 1 is a negative 3 as my final answer. Okay, over here for part B, it is a little bit different. Determine the value of x. Now it's asking me to find the number that needed to be plugged in that will get you an output of negative 8. Notice how this is written. F of x equals negative 8. That's telling me that wherever I see an f of x in the problem, I have to plug in negative 8. Well, I see an f of x right here, so I'm going to plug that negative 8 in place of that f of x. So negative 8, then I follow it with the equals x over 2 plus 1. It really, really, really makes a difference with your problem for whether you're plugging it in for your input like we did in part A or your output like we're doing right now for part B. Now this is an equation. It's not simplifying like the last three things that we did were. You have to use your equation rules to solve this, and you're trying to get x alone. You get rid of what's being added or subtracted first, so I'm going to start by subtracting 1 from both sides. So on the left side, negative 8 minus 1 is a negative 9, and then my equals x over 2 comes down. My goal is to get x by itself. Right now x is being divided by 2. To get rid of divided by 2, I'm going to do the opposite, which is multiplying by 2. So that these 2's cancel each other out. I'm just going to scoot up here. 2 times negative 9 is negative 18. My equal sign comes down, and since those 2's canceled out, I'm left with just an x, and I have determined the value of x like the problem had asked me to. All right, moving on to 195. Write the equation using function notation that represents the following scenario. So writing out an equation using a word problem. You currently have $90 in a bank account that pays no interest. You withdraw $7 each week. Write a formula for the balance B in dollars in the account after W weeks. So this is a formula for the balance. That's going to be B. And it is a function of the amount of weeks. So B of W equals. Now, don't worry too much about that. The rest of it is really what's important. So you currently have $90. That tells me right away I'm starting with $90. Now, key word in this problem is that we are withdrawing money. Withdraw money means you are going to subtract that money away from the 90 that you have in your account. You're subtracting $7, but not just once, not twice. You're doing it every single week. This word each means you have to put that with the variables, so minus 7W. Because you take out 7 per each week that you have. And that's it. No solving, no nothing. It just wanted you to write a formula for the balance. All right, next one with functions. 196 says state whether or not the following are functions and explain your answer. To figure out if a graph is a function, you have to do the vertical line test. If the vertical lines can be drawn through your graph and only touch the graph once, it is a function. If you draw vertical lines through your graph and it touches more than once, it is not a function. So I'm going to start by just drawing a vertical line anywhere on my graph. And I notice right away that it touches at 2 points. Because it touches at 2 points, that means it is not a function. And it does say to explain. So I'm going to explain by saying that it is because it fails the vertical line test. That's all you need to say. Another way of looking at it, if you prefer something else, I'm going to do this one in yellow. If you trace your graph, you shouldn't be going backwards and then forwards. The fact that this one goes backwards and then forwards tells me right away that it is not a function. However way you choose to look at it, perfect. Okay, part B, a little bit different because it's a table. For a table to test if it's a function, X can't repeat. Remember, your input is X, your output is Y. So if X can't repeat, all you have to do is check this input column and see if the X values repeat. I have a 10, a 5, and a 0. None of those repeated. The repeat would look like something like this. If I have 2 2s and like a 5 and a 4, whatever the Y values are. If X is repeating, that would not be a function. But because X is not repeating over here, that means yes, it is a function because X does not repeat. Okay, so this is just an extra example over here. Don't worry about that one in terms of this specific part B. I just wanted to show you what a table would look like if it was not a function. All right, let's move on down to 197. Okay, 197 is working with a table. It's that same input and output situation that we did in question 194, but now it's giving you all of the inputs and the outputs. You don't have to do any math to it. You just have to find it in the table. And what's most important about this is you know whether you're working with an input or an output. So remember, your entire function is f of x. This in here, the number in the parentheses, your input is the number right here in part A that's in the parentheses, which is 3. So part A is telling you that x is 3, but that's not your answer. It's asking you when x is 3, which would be this right here in the table, what is your output? Your answer is going to be 10. Now looking at it the other way for part B, if f of x equals 12. Well, look, here's f of x right here. If I go to where it's 12, the rest of the question says then x is equal to what? Well, x is equal to 4 when f of x is 12. You have to fill in the blanks with what it's missing given what you have. All right. 198, same idea, but instead of a table, now I'm using a graph. So g of negative 4. Same idea, it's telling me that x is negative 4. It wants to know what y is when x is negative 4. So I go on my x-axis to where x is negative 4, and I just scoot on up, and I look over. When x is negative 4, my y value is 3. And the next one, a little bit trickier. It's telling you when g of x is negative 3. The reason this one's a little bit trickier, and I'm going to draw in the line, when g of x equals negative 3, that means where y, or my output, is negative 3. There's two values where y is negative 3 on this graph, or where the graph goes down 3. There was only one value where x was negative 4. There's two values where g of x, or y, is negative 3. Those two x values are negative 2 and 0. So x equals negative 2 and 0 will be your answer for part B. All right, let's move on down. For 199, Sarah is driving her brand new car around. Her distance from home in miles is given as a function of time in minutes she has been driving. This function is represented by the graph below. Describe what might be happening between 10 and 20 minutes. So my minutes is down here at the bottom. Between 10 and 20 is this flat line on the graph right here. So take a look at your graph. As the x-axis goes on to the right, that means time is moving on. As my y-axis is going up, my miles away from home is going up. So your miles are changing as time is changing, but if you notice right here at this flat line between 10 and 20 minutes, time is going on. It's been 10 minutes, but at 10 minutes I was 4 miles from home, and at 20 minutes I was also 4 miles from home. What that tells us is that we didn't go anywhere before that 10 and 20 minute mark. So all you need to say is that you stopped moving. If you get creative, he was driving a car, so maybe he stopped to get gas, stopped to get food, needed a coffee, pulled over to be responsible and take a phone call, whatever it may be, as long as it's stopped. It does not mean that he's driving on flat land. Please make sure you are clear about that. All right, getting more into solving equations. So for 200, when you are trying to solve an equation, all it says is solve. Your goal is to get the variable by itself. Now, in this case, where you have an x on both sides of your equal sign, notice right here, draw the line if that helps you. You have to get them together in some way, and because they're on opposite sides, that means you have to do the opposite operation. So I'm going to move this negative 1x over to the other side by doing a plus 1x. Notice I put the plus 1x underneath the 6x because they are like terms and I can combine them. 6x plus 1x is 7x. I bring down the minus 14, I bring down the equals, and I bring down the 7 because those 1x's canceled. Now that I'm down to just one x in the problem, this is actually that basic form that we always go back to, and it's kind of nice, and you follow the same process from here. Get rid of what's being added or subtracted first, so I'm going to get rid of that minus 14 by adding 14 to both sides. That's going to leave a 7x on the left side. My equal sign comes down, and 7 plus 14 is 21. Then I get rid of that 7 with the x by dividing, because 7 and x next to each other means multiplication. The opposite of multiplying is dividing, so those 7's cancel each other out, and I get that x is equal to 3. Now for this question specifically, I am going to show you how to go over a check. Remember, you can check all of these, but you do not need to check them. My advice to you is if you have extra time at the end of the test, use that time wisely and check the answers that you can. So for a check, all you do is take the x value that you got as an answer and plug it in wherever there is an x in the problem. So I see two x's. First thing I see is 6x. Instead of 6x, I'm going to write 6 times 3. Then I see minus 14. I bring down my equal sign. Then I see negative 1x. I'm going to write negative 1 times 3 plus 7. Notice the equation that was given and the one that we just wrote are the exact same, except for the fact that we've plugged in 3 for x. all you're doing is seeing if x works in this equation. If 3 works in the equation, that means it's your solution. If it doesn't work, that means it is not your solution and you should go back and fix it. So I'm just going to simplify the left and right side to make sure that it's equal to each other. So 6 times 3 is 18. My minus 14 comes down. On the right side, negative 1 times 3 is a negative 3, and the plus 7 comes down. This does end up working out because 18 minus 14 is 4, and negative 3 plus 7 is 4, so it checks, and that means that 3 is my answer. Okay, again, checks are not necessary, but they can be used to check every single equation that you're solving, so absolutely use it to your advantage if you choose to do so. All right, for 201, I'm solving an equation again. I see 2 x's, but before I see those x's that need to be simplified together, I notice the distributive property. Anytime you have the distributive property, you have to do that first. So I'm going to start by distributing this 2 through to the 3x and the 2, and I'm going to stop at the 2 because the parentheses are after that, and you don't pass the parentheses. Okay, but in the next one, I have and watch out for this, a negative 4 that needs to be distributed to everything after. The distributive property is just saying, like for the 2, that 2 is multiplied to both of those terms, so it needs to be distributed through. Then it's a negative 4 times x minus 6. Well, there's 2 terms in there, so you need to distribute it through. So now I'm going to do the math, distributing. 2 times 3x is a 6x, and 2 times 2 is a plus 4. Again, this next part is tricky. I have a negative 4 times x, which is a minus 4x, and then negative 4 times negative 6 is going to be a positive 24, and the equals 12 comes down. Okay, so going back to 200 for a second, in that very, very beginning step, I noticed that there were 2 x's in the problem, but they were on opposite sides of the equal sign. This one, my equal sign is right here, and I notice that my x's are on the same side. So I have a positive 6x and a negative 4x on the left side of the equation. When they're on the same side, you just combine them. You do not move them to the other side because they're on the same side. So 6x minus 4x is 2x, and then I have a positive 4 and plus 24 that I can also combine together, which gets me plus 28, and that's equal to 12. Here's that basic form that we keep going back to. Get rid of what's being added or subtracted first. I'm going to get rid of that plus 28 by doing minus 28 to both sides. My 2x comes down, my equals comes down, and 12 minus 28 is a negative 16. That 2 and that x are being multiplied, so to undo it, change colors there, whoops. I divide by 2 on both sides, the 2's cancel, the x comes down, and negative 16 divided by 2 is a negative 8. Again, you can check. I'm not going to go over that check with you. If you decide to do the check, you should end up with 12 is equal to 12 at the end. So if you want to practice it, just make sure that works out. Okay, but again, you don't need to check. I will not take off points if you don't. Now, continuing on with solving equations, just adding a little bit more to it, function notation. So 202, given that f of x is equal to 2x minus 6, x is equal to 4x plus 3, solve the following. So if you look at A, it says f of x plus g of x is equal to 8. You can't solve that because there's nothing to combine. There's no math to do. What you need to do first is substitute in what the functions are. So A says that f of x is the first thing that I have. I have to take what f of x is up here, which is 2x minus 7, and plug it in for f of x. So 2x minus 7 gets plugged in for f of x in the first part of this equation. After f of x in part A, I see a plus sign. So I bring down the plus sign. Then I have g of x. So I'm going to do the exact same thing that I just did with f of x, but instead of 2x minus 7, I'm going to plug in 4x plus 3. Okay, so see how now we have an equation to work with. I've plugged in what f of x was, I plugged in what g of x was, I brought down the plus sign and the equals 8, and now I'm ready to simplify this. Okay, so I look at the setup, there's 2 x's, but they are on the same side of the equal sign, so I just combine them. I have a 2x and a positive 4x, which gets me 6x. And then when I combine my constants, a negative 7 plus 3 is a negative 4, and that's equal to 8. Here's that basic form, again, that we keep going back to. Get rid of what's being added or subtracted first. I'm going to get rid of that minus 4 by adding 4 to both sides. So the 6x comes down, and 8 plus 4 is 12. Then the 6 and the x are being multiplied, so to undo that, I'm going to divide by 6 on both sides, and I get that x is equal to 2. I can take that 2 and check it, but again, I'm not going to take off points if you don't check. I just want you to be aware you can check every single one of these problems. Okay, so same idea with the first step for part B, except the setup of the equation is different. I'm still going to plug in f of x where I see f of x, and g of x, which was 4x plus 3, in place of g of x. So the first thing I see is f of x. I'm going to plug in 2x minus 7. My equal sign comes down, and then I plug in what g of x is, which is 4x plus 3. Here's why this one is much different than part A. Your equal sign is between your two x's, so you have to move one of your x's over to the other side. I told you guys in class, if you don't like negatives, always move the smaller x to the other side. It does not matter which one you move over. If you move the 4x, the positive 4x to the left side, you'd be subtracting 4x over and you'd end up with a negative, which is fine as long as you're good with negatives or even just good with negatives in your calculator. I'm going to stick to what we've been doing and move the smaller over. So to move that positive 2x over, I'm going to subtract 2x. Again, notice that I put it under the 4x because they're like terms. So the negative 7 comes down on the left side. My equal sign comes down. 4 minus 2x is 2x. And the plus 3 comes down. Even though it's backwards, this is that basic form that we keep going back to. My goal is to get x by itself, and I do so by getting rid of what's being added or subtracted first. To undo plus 3, I subtract 3 from both sides. What you do to one side, you have to do to the other. Okay, on the left side, I have negative 7 minus 3, which is a negative 10, and that's equal to 2x. 2 and x are being multiplied, so to undo that, I divide both sides by 2, and negative 10 divided by 2 is a negative 5. So my answer is x equals negative 5, or negative 5 equals x. All right, let's keep going with this. For 203, solve the following. These are those out of the ordinary equations that we really only did a couple of, but you can expect to see it on your test. So when I'm solving A for 203, the first thing that I notice is that they have the distributive property. You always distribute first if there's the distributive property in a question. So 2 times 2x is 4x, and 2 times 4 is a plus 8, and then I bring everything else down, equals 4x plus 8. Hopefully you notice that the left side is identical to the right side. If you already know what the answer is at this point, you are good to state that solution. If not, I'm just going to take you a couple of steps further and move on with this. So to solve this, I have 4 x's on both sides. I would have to do the opposite operation to move them over to the other side of the equation because they're on opposite sides of the equation. What happens though with this out of the ordinary situation is 4x minus 4x cancels on both sides, and you end up with 8 is equal to 8. Kind of weird because you don't have an x to solve for anymore. So on your test, it's not going to tell you that it's going to be a weird scenario. You're going to have to recognize it. The way that you recognize it is when this exact situation happens, where your x's cancel on both sides of the equation, and you don't have an x to solve for anymore. So there's 2 different situations. One is going to be what we see right now in part A. The other one's going to be part B, which we'll get to in a second. But first for part A, with 8 is equal to 8, what that tells you is that the left side is always going to be equal to the right side, whether x is 1 or I check a solution of 2, 3, 7.5, pi. If you plug in any number for x, the left side is always going to equal the right side, which tells you that there are infinite solutions. Now, on your test, you have to state that as your solution. It's the answer. You can't just say 8 equals 8 and done. You have to state that there are infinite solutions. Or, if it's more along the lines of what we're seeing in part B, same thing. You have to make sure you state your solution, but I'm going to set you up with this to start with the distributive property. So 2 times 2x is 4x, and 2 times 4 is a plus 8. Same situation as the first one. But now I have that 4, what is going on? 4x. Sorry, it's equal to 4x plus 4. That was weird. Okay, so 4x plus 8 is equal to 4x plus 4. You might notice right away that these are not equal to each other. I gotta fix that, it's driving me nuts. Okay, 4x plus 4. Okay, you should be noticing that the left side is not identical to the right side like it was in part A, but I can do what I did in part A to see it a little bit further if you didn't already, because again, while you're taking your test, you're not gonna just know that these are out of the ordinary situations. When I subtract 4x from both sides, it goes away on both sides, and I get that 8 is equal to 4. Here's why this one's different. They are not equal to each other. So that tells me that if I plug in any number for x, again, like 1, 2, 3, etc., I'm going to have that 4 times that number is on both sides, but on the left side I'm adding 8, and on the right side I'm adding 4. I will never, ever, ever get the left side to equal the right side no matter what number you try to plug in for x. It will never, ever work out. What that tells me is that there are no solutions. And again, you have to state that there are no solutions. Saying just 8 doesn't equal 4 is not enough. Your solution is that there are no solutions. All right, let's move on to literal equations. Literally everyone's least favorite thing on the test. So I will give you guys that are watching this video a little bit of a hint for the literal equation that is on your test. It is going to give you a message, just like A is going to give you a message. You might not see it now unless you've already tried the problem, but I'm going to walk you through it and you'll notice that there is a message at the end. And again, there will be a message on your test. So if you're getting something that's not a message, chances are yours is incorrect and you're going to want to fix that. Okay, so for A, you are solving for W. What that means is you have to get this letter W by itself. Right now, W is being divided by LP. I have to undo that by doing the opposite, just like I would for any other equation. So to undo dividing by LP, I'm going to multiply both sides by LP. And I'm going to make a cursive L just so you can see that it is an L. So over there on the left side, again, my goal is to get W by itself. I know W is being multiplied by ME. We're going to hold off on that for now, and you're going to do that on your test too. But it's being divided by LP. I got to get rid of that first before I can even start dealing with that ME. The opposite of dividing by LP is multiplying by LP. So these cancel each other out. So on the left side, you're just left with MEW is equal to, and I have HE times LP, which is just going to be help. Okay. When you put letters next to each other, it means they're being multiplied. You could have brought down the parentheses. It would not be wrong. You just get rid of them if you can to make it look a little simpler. Okay, so that was the first step. Now moving on to my second step to get that W by itself. The last thing that's happening to W is it's being multiplied by ME. So to undo multiplying by ME, I'm going to divide by ME. So those cancel, and I end up with W equals, help me, help divided by me. There's your message. People generally need help with these literal equations. I thought that'd be kind of funny. Help me with solving these. Okay, it will not be the same message on the test, just to make that clear, but you should expect a message. All right, part B. Z equals A minus 2B minus 4, and you're solving it for B, which means you're trying to get B by itself. Okay, so I need to get rid of what's being added or subtracted first. What that tells me is that I'm going to get rid of that negative 2 last because it's being multiplied to the B. Everything else, the A and the 4, are being added or subtracted, so I move those first. It does not matter which one you move first. So I'm going to get rid of that minus 4 first by adding 4 to both sides. If you get rid of the A first, that is perfectly fine. Okay, so I am going to have Z plus 4 on the left side is equal to A minus 2B on the right side because, again, those 4's canceled each other out. So on the left side, notice that I wrote Z plus 4. A lot of people make the mistake of writing 4Z. 4Z means they're being multiplied, not added. So you can't write it as 4Z. You literally have to write it down exactly how you see it, Z plus 4. Okay, again, my goal is to solve for B. We said we have to get rid of that negative 2 last because it's being multiplied. So I'm going to move the A over now, and it's a positive A. So I'm going to subtract it over, so those cancel. Same idea. I can't combine anything on the left side, so I bring it down exactly how I see it. Z plus 4 minus A, and that's equal to negative 2B. Okay, get rid of that negative 2, which is being multiplied to B, by dividing everything by negative 2. Those cancel out, and I leave my answer as is. Z plus 4 minus A over negative 2 is equal to B. A lot of people are tempted to divide that 4 by the negative 2. You can simplify that, but if you do that, and this is a big if, don't do it unless you want to, you have to divide everything by the negative 2. So the Z would be over negative 2. Then you could do 4 divided by negative 2, which is a minus 2. And then negative A divided by negative 2 would be a plus A over 2. I think that looks a heck of a lot uglier than what we boxed in, but it is absolutely correct if you wanted to simplify that 4 divided by negative 2. But don't do it unless you want to. All right, 205. Determine the inverse of the following. So big thing with inverse that you need to remember is that you switch x and y, then you solve for y. So it seems weird in the beginning to switch x and y, but that's the idea of inverse. So where I see a y, I'm going to put an x equals 1/3. Where I see an x, I'm going to put a y, and the minus 2 comes down. That's my first step for inverse. My second step is to then solve for y. So get y by itself. It's another literal equation. Get rid of what's being added or subtracted first. So to move that minus 2 over, I'm going to add 2 to both sides. X plus 2 comes down exactly how you see it. X plus 2 is equal to 1/3 y. Remember, with fractions, to get rid of them, you multiply by their flip. Multiplying by 1/3 is like taking a third of something. Taking a third of something is dividing by 3. The opposite of dividing by 3 is multiplying by 3. I know that's a long way of thinking about it, but that's exactly what's happening there. So the 1/3 times 3 cancel each other out and leave you with a y. And you can leave your answer as 3 times x plus 2. Or if you'd like, you can distribute that 3 through and get 3x plus 6 is equal to y. But remember, your inverse notation is to put a negative 1 up there with your y. Either one of those answers would be correct. This answer right here is just your distributed answer. Up to you if you want to take that extra step. All right, going back to some word problems and simplifying it down to write it as an equation using that algebra. So it says Janet took an Uber home from a party. The fare was $2.40 per mile, and she gave the driver a tip of $6. Janet paid a total of $20.40. A says to write an equation to represent this situation. So the biggest and most important word in this entire problem, in my opinion, is per. That tells you that that is the number, that $2.40 is the number that's going to change depending on how many miles. So you have to multiply that 2.40 by the total amount of miles. We don't know what that is. That's going to be our unknown in this problem. I'm going to call it M. You can call it X. It doesn't matter, but it's going to be your variable. So that $2.40 is going to be multiplied by M. So if I were to drive 7 miles, that means it'd be $2.40 times 7. But then she also gave the tip of $6. So on top of that, or in addition to that, I'm going to have plus 6. Now, when all is said and done, we paid a total means equals $20.40. The directions for part A were to write an equation. That means I am done. I've written the equation. I've done all that I was asked to do, and we are all good. But part B is asking me to use the equation to find the distance between the party and Janet's home. In other words, how many miles did this Uber take her? That's going to be M, the amount of miles that she paid for. So, in other words, this is telling you to find M, or solve for M. So this, even though there's decimals, it's in that basic form. You're trying to get M by itself, so get rid of what's being added or subtracted first. So I'm going to start by subtracting 6 from both sides to get rid of that plus 6. So the $2.40 with the M comes down. And 20.40 minus 6 is 14.40. Now, M is being multiplied by 2.40, so I divide it by 2.40 to get rid of it. Notice how important it is to know how to solve an equation. If you don't know how to solve an equation, it's going to give you a hard time, not with just the solving equation problems, but even these word problems like this. Solving equations is going to come up a lot. Okay, so 14.40 divided by 2.40 is 6, and that means that the distance between the party and Janet's home was 6 miles. All right, here we go with percentages. Okay, not a whole lot you need to know about percentages, but the biggest thing is how to convert a percentage to a decimal. So let's read the question first. For 207, it says, on a restaurant bill of $49.52, how much money, rounded to the nearest dollar, which will be important at the end, should be left as a tip if they want to tip the waiter 20%. So that means I have to find 20% of this number. To find a percentage of something, you have to multiply that something by the percentage as a decimal. So I need to convert 20% to a decimal. There are two ways of doing it. You can either divide it by 100, because remember, percentages are out of 100, and that will get you 0.20. Or right from this spot in the problem, you can take that imaginary decimal point that's at the end of every whole number and scoot it to the left 2 places, which will also get you 0.20. Both ways are effective and will get you the right decimal. Now, like we said, we're converting that percentage into a decimal so that I can multiply it by that total bill, which is $49.52. So that's going to be times that 0.20. Okay, plug that in your calculator and you're going to get yourself 9.904. So that means about $9.90, but then I go back and I read again that it needs to be rounded to the nearest dollar. Nearest dollar just means nearest whole number. Think about it not so much as rounding, especially if you have a hard time with rounding, and more in terms of money. If you have $9.90, is that closer to $9 or $10? It's going to bump itself up to $10. If you think of it like rounding and you're rounding to the nearest whole number, you look at that digit after, 5 or above, give it a shove. That's going to bump that $9 up to $10 anyway. So however you want to look at it, round it to the nearest whole number or the nearest dollar is going to be $10. All right, getting into inequalities. If you haven't yet, make sure you memorize those inequality symbols. Part A has a greater than, and part B has a less than or equal to and a greater than. You've got to have those memorized. So the directions say solve and graph the following inequalities on a number line. So I'm going to solve them first, and then I'm going to throw them on a number line when I am done solving. So part A, I have to get that x by itself. This is in that basic form. Even though it's a little bit flipped around, I still have to get rid of what's being added or subtracted first, which will be that first 10 I see. It's a positive 10, so to move it over to the other side, I'm going to subtract 10 from both sides. Be cautious about bringing down that number on the left side. It's a negative 10x. The greater than comes down, and 100 minus 10 is 90. Okay, to get x by itself, I'm on my last step. Get rid of what it's being multiplied by dividing by that negative 10. Now, huge red flag here. I'm dividing by a negative. When you have an inequality and you divide by a negative, you have to flip that sign. So it is no longer a greater than, it's a less than. It's going to change where you shade. And then 90 divided by negative 10 is a negative 9. So I originally told you we're starting with a greater than. When you solve, you divide by a negative, you flip that sign, and now it's a less than. Okay, so I'm going to go ahead and draw out a number line. Nice and straight. The most important number on this number line is the number that I have in my solution, which is negative 9, and then just put a couple of numbers around it as context. Remember, as numbers get bigger in the negative direction, their value is actually smaller. So negative 10 is to the left, which is a smaller number than negative 9, and negative 8 is to the right, which is a bigger number than negative 9. Okay, to graph this on a number line, you have to ask yourself two things. First, whether this symbol gets you an open or a closed circle, and then whether you shade to the left or to the right. Because it does not have the or equal to, that -9 is not included in the solution, which means it's not included in the shading. It's going to be an open circle. If it had the or equal to underneath it, it would be a closed circle, but it doesn't, so it's an open circle. And less than is going to be shaded to the left, where numbers are less than -9. So I'm going to shade on my number line towards the left, and that covers all of my number line. All right, part B says 10 plus r is less than or equal to 12, or 5r is greater than 30. A lot of people tend to think when taking the test that means solve one or the other. Just pick whichever one you feel like. That's not the case. This is one whole problem. You have to solve both of them, or it'll come into play later, and I'll explain it a little bit more once we get there. But that or just means you're splitting up two inequalities. Whoops. Sorry about that. So I need to solve this one over here and solve this one over here separately, and then again we'll talk about what that means later. So the 10 plus r is less than or equal to 12. I have to get that r by itself by getting rid of that +10. That +10 can move over by subtracting 10. So the r comes down, the less than or equal to comes down, and 12 minus 10 is 2. So one of my solutions is that r is less than or equal to 2. That or is just going to come down. My other one is 5 times r is greater than 30. To get rid of that 5 that's being multiplied to the r, I'm going to divide both sides by 5 so that those 5's cancel, and I get r is greater than 6. Notice that I didn't flip the sign for that one because I was dividing by a positive number. I only flipped the sign over here because I was dividing by a negative. So make sure you keep that straight as well. So my solution is that r is less than 2 or r is greater than 6. Here's where that word or comes into play, and then we'll put this on a number line. Okay, so the or is so important for this because you do have infinitely many solutions to inequalities. Just like we did in part A, every single number less than -9 to negative infinity is going to be a solution. For this one, I have r is less than or equal to 2 or r is greater than 6. Or just means that there are no numbers that fit both of those criteria. There is not a single number that is less than or equal to 2 and bigger than 6. You are either less than or equal to 2 or you are bigger than 6. That's why the word or is there, and it'll also help you out with the shading because you're not going to have a shaded area where they are shared. So just like for A, where I made sure the -9 was on the number line, for this one I just have to make sure that the 2 and the 6 are on the number line. So I'm just going to try and spread this out as best as I can to make sure that that 2 and 6 are on the number line. Now you have to graph each one separately. So what you have to ask yourself again is whether each one of those has an open or a closed circle. So starting with r is less than or equal to 2. That or equal to tells me that it is part of the solution, aka it is part of the shading, so it's going to be a closed circle. Whereas the r is greater than 6 does not have the or equal to, so it is going to be an open circle. Only a closed circle when you have the or equal to. Okay, now I go with the shading. The first one, r is less than or equal to 2, tells me that I'm going to shade where numbers are less than 2, which is to the left. R is greater than 6 tells me I'm going to shade where numbers are bigger than 6, which is to the right. Notice the shading doesn't overlap. You are either over here in this shading or over here in this shading. Nowhere do they intersect. So what that tells me is that 7 could be an answer. 1 could be an answer. 4 is not. It's not in the shading. 6 is not. It's not in the shading because that open circle is not included. 2 is a solution because it's part of the shading. All right, moving on to graphing on an X and Y axis. So they are not labeled on your grids, but do remember Y to the sky. So Y is always going to be your vertical axis. X is going to be your horizontal. Now, one other thing you need to remember about graphing any line, oh, it's doing it again. There we go. Is that you need to get into that Y equals mx plus b form. If you can't remember that mx plus b part, just remember that your goal is to get Y by itself. So if my goal is to get this Y by itself, I've got to move that plus 4 over to the other side. And I'm going to just show my work over here by writing that equation real quick. To get that plus 4 to the other side, I have to do the opposite, which is minus 4. So that plus 4 and minus 4 cancel each other out. My Y equals comes down, and I can't combine those. One of the terms has an X, the other one doesn't, so they're not like terms. So the negative 2/3 X comes down, and the minus 4 comes down following it. And that is Y equals mx plus b form. So before I graph this, I'm going to state what m and b are. So m is the number in front of x, which is negative 2/3. That's a good sign. I want my slope to be a fraction. Remember, if it's not given as a fraction, you have to turn it into 1 by putting it over a 1. And b is the number by itself, which is going to be a negative 4. I've got this plus b over here, and I have a minus 4. So b is negative 4. So to graph this, you always start at B, which is your y-intercept. So I'm going to put a point on my y-axis at negative 4. And then your slope is rise over run. And I know it sounds funny, but you're going to rise a negative 2, which is down 2, and you always run right. So from that negative 4, I'm going to rise down 2 and run right 3. Down 2, right 3. Down 2, right 3. And you run out of grid. If that happens to you, make sure you go in the other direction as well. Down to right 3 is also up to left 3. I know I just said you always go right. You only go left when you're doing the complete opposite. So you start with right always, and then you go left doing the opposite up to left 3. I'm going to do my best to try and connect this with a straight line. You do your best to try and connect it with a straight line. That was not even close. There we go. Arrows on the end once you connect those, and you are done. So I know in class we did a lot with solid and dashed lines, where it's shaded and whatnot. We are going to get into that. That is with inequalities. When you just have an equal sign, you don't shade. When you have something like this next question, 210, you have to worry about solid or dashed and where it is shaded. What is nice about this specific question for 210 is that y is already in mx plus b form. So I have y is greater than 2x plus 3. I'm going to start by stating what m and b are. So m is the number in front of x, which is a 2. Remember what I said in the last problem? To turn it into a fraction, you just put it over a 1, and you always want your slope to be a fraction. Okay, and then b is the number by itself, which in this case is 3. So given that it's an inequality and I have more to do after I graph it, I still start by just graphing the line like there's nothing else to it. So I put a point on my y-axis at 3, my y-intercept. Then from there I have to rise positive 2, which is going to be up 2, and I always run right, and I'm going to go right 1. So up 2, right 1, up 2, right 1, up 2, right 1. Once you can't go up to right 1 anymore, same as the last problem, you're going to go the complete opposite, down to left 1, down to left 1. If you do down to left 1, down to left 1, whatever it may be for your whatever slope you're working on, and you end up with something that doesn't look like a line, you may have missed a box or miscounted or maybe started going like 1 over 2 instead of 2 over 1. Just make sure it's a perfect line when you're done. If it's not, you got something weird going on. Okay, don't connect it until you consider your inequality sign. So I have a greater than. Greater than tells me that it's going to be a dashed line. It's only a solid line if you have that or equal to underneath. Like if you look ahead for 211, I have that or equal to, so that'll be a solid line. This one's going to be dashed because it doesn't have the or equal to. So I'm going to connect this real quick with a dashed line. Arrows on the end still. Okay, so while you're graphing that, just to give you a tidbit of what that means, remember what we talked about in class. If you have a point on a dashed line, it's just like that open circle concept on the number line. It's not included. So all of those points that we plotted on that line are not part of the solution. So you might be asking where the solution actually is. I'm not done with graphing this because I now need to shade it. Because it is a greater than, that means I'm going to shade up. So shade towards the top of the graph. Here is where my shading falls. That's where all of my solutions are going to be, in the shaded area. None of the red points on my grid are part of the solution, just what's in the shading. So where it says for part B, to name a possible solution to this inequality, this point over here that I'm putting in yellow, right there on the bottom right, like 9, -7, is not a solution. Okay, the point that I'm putting in green for go over here, is a solution because it's in the shading. So that point, my sample point, is going to be -10, 5. And you can put any point in the shading. You could even say -12, 1. It's not in the grid, but the grid does go on forever, so that would be a solution as well. It'd be in the shading. Okay, just not a point that's not in the shading, and not one of those red coordinate points that are on the line. All right, let's move on to the next one. Again, kind of nicely set up because it's already in y equals mx plus b form, so I'm just going to rewrite it over here on the right side. And I'm going to state what m and b are as though I was graphing this like a regular equation, not worried about solid or dashed or shading at all right now. So m is the number in front of x, which is -3. I need it to be a fraction, so I put it over a 1. And b is the number by itself, which is a +3. Make sure you clarify which one is which. So that means I'm going to start graphing on my y-axis at +3, and I'm going to rise down 3, and I always run right. So down 3, right 1, down 3, right 1, down 3, right 1. When you can't do that anymore, you're going to go up 3, left 1. All right, once you have that graphed, refer back to that sign. I have a less than or equal to. The or equal to tells me it's going to be a solid line, and the less than tells me that I'm going to shade it down. So I'm going to connect it with a regular solid line as best as I can. That was rough. Let's try that again. There we go. Still pretty bad. A little bit better. And then I'm going to shade it down, so towards the bottom of the graph beneath this line is where all of my solutions fall in the shading. Okay, so a good point and a bad point. Again, for B, a bad point would be this yellow point over here. Bad, 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 bad. It is not in the shading. Good point would be, let's say, this one right here. Okay, that point is -8, 0. There are infinitely many answers that you can put as a possible solution to the inequality. As long as it is in the shading, you are good to go. All right, let's go ahead and flip. Get away from graphing for a little bit. Get to some more algebra. So for 212, it says determine the slope between the points -2, 2 and 0, 10. On your test, you will be given the formula for this. I apologize that it is not given to you on your review packet. I will always make sure that you have formulas for you on your test. but you do need to know how to use them. So what we're doing right now is if we were to graph the point -2, 2 and 0, 10, you would check out your rise over run and see what your slope is. Those points are pretty far from each other and we don't have a grid to graph them on. That's what this formula is going to do for you. So to use the formula, you need to label your points as x1, y1, x2, y2. It doesn't matter which points you label, x1, y1, x2, y2, but you can't do x1, y2 together in one point. Your 1s and your 2s must stay together. So when I go to plug this into that formula, first I plug in my m equals, and then I write my y2. So my y2 is 10. Next in the formula is a minus, and then my y1 is labeled as 2. Be careful with this bottom part. x2 is 0. So I plug into 0. I bring down the minus from the formula, and then x1 is a -2. That negative is not already accounted for because I have the minus sign there. You have to put them both. Okay. A minus and negative is just going to become a positive, and that's all that's going to change about that minus and negative. So on top, 10 minus 2 is going to be an 8. And 0 minus a -2 is going to be a +2. 8 divided by 2 gets me 4, so my final answer for the slope is 4. All right, next one. Take us a little bit further, but using that same formula. No, we don't need the formula, I'm sorry. For 213, it says determine the equation of a line with a slope of 2 that goes through the point 2, 12. So the fact that it gave me the slope means I don't need that formula, duh. It just told me what m is already. So if I just take what I know already, y equals mx plus b is what my goal is because it's asking me to find the equation of a line, and it tells me that the slope is 2. So y equals 2x plus b. The only two pieces you need to write out the equation of a line is what m is and what b is. M is 2. I now need to find what b is. Now, in the problem, it did give me this extra piece of information. It gave me an x value and a y value. It gave you that for a reason. You're going to plug those points into this to help you find b, and I'm going to do that off to the side. So in place of y, I'm going to plug in a 12. I'm going to bring down the equals. The 2 is going to come down. And then in place of x, I'm going to plug in a 2, and then the plus b comes down. Okay, so 12 comes down. I'm just going to math this out. 2 times 2 is 4, and then the plus b carries down. And to get b by itself, I get rid of that +4 by subtracting it to the other side, and I get that b is 8. So now that I have m and I have b, I'm going to write out that final answer in y equals mx plus b form as y equals 2x plus 8. All right, moving on to the next one. This one you need the slope formula for again. So determine the equation of a line that goes through the points 8, -3 and -4, 1. So just to reiterate, in order to write the equation of a line, you need m and you need b. In the last one, we were given m and we only had to find b. For this one, we have to find m first and then, also find b. So to find m, I'm going to use that formula again, which again will be given to you. So y2 minus y1 over x2 minus x1. And I'm going to, I'm going to label my points as x1, y1. And x2, y2. And then I'm going to plug them in. So my m is equal to y2 is 1 minus my y1, which here's that situation again, is a -3, over x2, which is -4, minus my x1, which is 8. On the top there, that minus the negative just becomes a plus sign, and now I simplify. So m is equal to, on the top I have 1 plus 3, which is 4. And on the bottom I have a -4 minus 8, which is a 12. Okay. You can leave the 4 divided by negative 12. It's just an ugly fraction. To simplify that, it's just going to be 1/3, and the negative can just pull right in front. So my slope is negative 1/3. I have only found M. Now I need to find B. So I'm going to find B the exact same way that I just did up here, where I plug M into y equals mx plus b, and then I plug in a point for x and y. So I found my slope. Now I'm doing exactly what I did in the last question. So I'm going to write out y equals m, but instead of m I plug in negative 1/3 x plus b. It does not matter which point you use because both of those points should be on the line. Try and use the one with nicer points. I'm going to use this one. So my y value is going to be 1 equals negative 1/3 times that x value, which is negative 4. Close my parentheses and bring down the plus b. The whole point in plugging in that x and y value is so that now you only have one variable in the equation as opposed to the 3 that we had before. I can now solve it for b. Okay, so the 1 comes down, the equals comes down, and I've got to simplify this fraction times the number right here. I assure you I will not give you a calculation that is this difficult on the test. All you've got to do is multiply them together, and you can use your calculator if you'd like. It'll end up getting you 4/3. And when you multiply fractions, if you want to try it in your head, you just multiply straight across. Negative 1 times a negative 4 is a positive 4, and 3 times 1 is 3. And my plus b comes down. Okay, now to get b by itself, you just have to get rid of that positive 4/3, and you do so by subtracting 4/3 from both sides. So I subtract 4/3 here, subtract 4/3 here, and again, there will be nicer numbers on your test, I assure you, but 1 minus 4/3 is a negative 1/3, and that is my b. So M and B are now known. They just ended up to be the same thing, which is a little strange, but it worked out nicely. So I just plug them into that final form to write the equation of a line, y equals negative 1/3 x minus 1/3. That's my final answer. All right, let's pull that down to the next one. So this one you're definitely going to want to practice plugging into your calculator. It's all done in the calculator. And as I told you before, I will give you these step-by-step instructions on your test, just like you saw on a previous quiz. All right, so working this out on the calculator, it says Emma is taking a road trip. She decided to keep track of how many gallons of gas she used along the way. The results are shown in the table below. So part A says determine the equation of the line of best fit using linear regression. That's exactly what the directions are going to say every time it wants you to do this step by step in the calculator. Round all values to the nearest hundredth once we get there. Okay, so step 1 is to press stat. So stat is on like the top middle of your calculator, and then you press edit or enter at that point. Your left side, your miles driven, is going to be your L1. Your L2 is going to be the number of gallons used. So to clear them out, you highlight over L1, press clear enter. Use your arrows to highlight over L2, press clear enter, and you should have a completely cleared list. Step 2 says to enter the x values into L1, so you're going to go to L1 and type in 160, enter, 210, enter, and so on, and then do the same thing with your L2. You put your y values, which is your number of gallons used, into your L2, so 8, enter, 11, enter, and so on. So if you need to pause it for a second to just make sure that you get those numbers plugged in, absolutely go for it. But I'm going to move you on to the next step. So step 4 is to press stat again, that first button that we pressed in the top middle of the calculator, and then you scroll right by pressing the right arrow and get to calc. It'll highlight over calc on the top of the screen. You scroll down to choice 4, which says lin reg. It's just an abbreviation for linear regression, and then follow step 0.05. Enter until the results show up. So you just keep pressing enter, 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 until you end up with this. I'm just going to write the information you should be seeing on your screen. So again, this is what you should be seeing on your screen. You should be seeing R values as well, but I will talk to you about that a little bit later on. Okay, the reason that R does not matter right now is because this right here is technically your answer. You're just not done yet. So y equals ax plus b is the equation of the line of best fit. Instead of a mx plus b, the calculator uses ax plus b, but it's the same idea. All you need to fill this out is a and b. Here's a right here, here's b right here. That's why r does not have an impact yet. So I'm going to plug a in for a in the equation and b in for b, but I have to round them to the nearest hundredth. So first, to the nearest hundredth, a. Remember, hundredth is 2 places after the decimal point. If it helps you to remember that 100 has 2 zeros and it's 2 places after the decimal point, please use that as a reference. The only thing that's tricky about that is I know I need 2 places after the decimal point. I have to refer to that third digit after. If it's a 5 or above, I give that a shove. 1 is not big enough, so I leave it as 0.05. For rounding b, I do the same thing. 2 places after the decimal point, but I look at that third digit. If it's a 5 or above, I give it a shove. This one's also not, so I'm going to leave it as negative 0.43. And now I have rounded to the nearest hundredth. I still am not done. This is my last step. Substitute the values into that equation form. So do what I just said in these arrows over here, where my answer is y equals ax, so I write 0.05x, plus b, so I'm going to write minus 0.43 because it was a negative number. This is the equation that you get from the calculator. So knowing how to do those steps is only half the battle. You then have to know how to round and plug them in for a and b. So make sure you practice with this whole problem. All right, now talking about those R values. So on your test, it's going to say what is the correlation coefficient, and then it's going to specifically tell you that's the R value in your calculator. So it should be very, very easy. You just copy it from your calculator. In this case, R was equal to 0.99921857774. There is also an R squared on your calculator. You will never, ever, ever use R squared in this course, so don't ever worry about it. Okay, but this R value is called your correlation coefficient, and basically it describes to you.
I'm reminding you, fix the sink.
Sorry, my Alexa just went off in case you couldn't hear that. Alexa, cancel. All right, so it says, what is the correlation coefficient? What does this tell you about the relationship in the data? That number is going to explain how strong the correlation is or how weak the correlation is. And it's all based on that number line from the notes, or the very much easier concept of the closer it is to 1, the stronger it is. If it helps you to think about the decimal like money, absolutely do so. This is 0.999. That's like 99 cents. It's really, really, really close to $1. So this one is definitely going to be a strong relationship. You also need to state whether it is positive or negative. Because this R value is positive, that means it is a strong, positive relationship. And remember, relationship is just another word for correlation. So it doesn't matter which one you state, but these are the 2 words that are the most important. The closer it is to 1, the stronger it is. So just a quick little side note before we move on to part C. If this R value were to have been negative 0.99, it's still strong. It's still close to 1, but it's just going to be strong and negative. Okay, so keep that in mind. The closer it is to 1, the stronger it is. Okay, if you're at like a 0.5, just remember from the notes that's a more moderate relationship. A negative 0.5 would be a moderate negative relationship, and 0 is as weak as your relationship can get because it's as far away from 1 and -1 as you can possibly be. You will not see a correlation coefficient bigger than 1 or bigger, or technically smaller, than -1. It's not going to be a 2 or a 3 or a -4. It's always going to be between -1 and +1. Okay. Part C, does this data and situation represent causation? Remember what causation means is that it has a cause and effect relationship. It's kind of in the word. Causation is cause and effect. So I'm going to go back up to this problem. We're talking about the miles driven and the number of gallons of gas used. Does it make sense that driving more miles causes the number of gallons used to change? It absolutely does. So this one does represent causation. And I have to explain. The only way to explain that is to just say because the miles driven affect the number of gallons used. You could also instead say because the number of gallons used causes the number of gallons used is caused by. That makes more sense. Yes, the number of gallons used is caused by the number of miles driven. So either using the word cause or effect, okay, whichever word you choose to use, is best to explain that cause and effect relationship. The one that we talked about during class that was correlation, it had a strong correlation, but it wasn't causation, there's a distinct difference between the two, was the age and height. Just because you get older doesn't cause your height to change. Yes, there's a strong correlation. As you get older, your height tends to change, but it doesn't cause it to happen. A big difference between correlation and causation. All right, moving on. Number 216. Getting back to some graphing. I know how much we love graphing. Okay, solve the following system of equations graphically. When it tells you to solve it graphically on the test, that means you have to use the grid. You can't use any of the algebraic methods that we went over during class unless it says to solve it algebraically. This one says to solve it graphically, which means I have to graph each of these equations on the same grid. So my first one is y equals 7 minus 3x, which is kind of nice. It's already in that y equals mx plus b form, so I'm good to graph it. M is the number in front of x, which is a -3. I want it to be a fraction, so I put it over a 1. And b is the number by itself, which is 7. So I graph it just like I graphed those other equations. I'm just going to do it one at a time. I start by putting a point on 7 on the y-axis. And then my slope is to rise a -3, so rise down 3. And then I always run right. So right 1, down 3, right 1, down 3, right 1. When I can't go down 3, right 1 anymore, I go up 3, left 1. Okay. These are not inequalities, so I just connect it with a solid line, no thought to it, no shading, no nothing. It's just an equation. Once you're done with that one, you move on to the next one, which unfortunately is not in y equals mx plus b form. So solving for y means I have to get everything else over to the other side. I get rid of what's being added or subtracted first, which is that -4, and I move it over by adding 4 to both sides. So the 2y in the equals comes down. Negative x and 4 are not like terms, so I bring it down as negative x plus 4. Okay, y is not by itself, but it's almost there. I got to get rid of that 2 that's being multiplied by dividing everything by 2. Make sure you write it out with everything. And then you do some math to simplify. So this x has a -1 in front of it. -1 divided by 2 is just -1/2. It does not simplify. So I'm going to leave it as -1/2, and the x is just going to come down. Don't stress that it's a fraction. It's actually good that it's a fraction because we want slopes to be fractions. And then 4 divided by 2 is 2. So I'm in y equals mx plus b form. I state what m and b are, and I go ahead and graph it just like the one before. So m is the number in front of x, which is -1/2. b is the number by itself. So I start by graphing b on the y-axis, and then from there I'm going to rise a -1 and run right 2. So I know sometimes when you're graphing lines it seems pointless to go the opposite direction and make sure you put as many points on the graph as you possibly can, but when you're working with a system it's crucial because you have to graph every single point in order to determine where they intersect, which is ultimately going to be your solution. We'll get there in a second, but make sure you plot every point. For this one it actually worked out quite nicely because they intersected right away, but if they didn't intersect right away you'd want to make sure you had all of your points plotted so that you can see where they intersect. Just a reminder to make sure that your points look like a line once you are done. If you accidentally mess up your slope or you miss a point or you count wrong real quick and make a mistake, it won't look like a perfect line, and that'll be an indicator that something went wrong. So they should both be connected at the end. You'll want to see where they intersected. That is going to be your solution. Your solution needs to be written as x comma y because it's a coordinate point. That x value at that intersection point is 2 and the y value is 1. So my solution is 2, 1. All right, so that was graphing a system of equations. For 217a, I'm going to graph a system of inequalities. Same idea with graphing each of them individually on the same grid, but now I just have to include whether it's solid or dashed and whether there is shading up or down. So I'm going to graph these just like their normal lines to start with. So y minus 1/4 x is less than 5 is my first one. I can't graph it until I'm in y equals mx plus b form, so I have to move that minus 1/4 x to the other side by adding 1/4 x to both sides. So I bring down the y, I bring down the less than. 5 and 1/4 x do not combine because they are not like terms, so I just bring it down as is. Okay, that's y equals mx plus b form. Even though m and b are flip-flopped, it's all good. I just need to remember that m is the number in front of x, which in this case is 1/4, and b is the number by itself, which is 5. So that tells me I start graphing a point on my y-axis at 5, and then I'm going to rise a positive 1, so up 1, and I always run right. So from that point I go up 1, right 4, up 1, right 4. I ran out of space, but I want as many points as I can. Down 1, left 4, down 1, left 4. You can always do the complete opposite. Don't connect them quite yet. I look at that sign. I have a less than sign. Less than tells me that it's going to be a dashed line because I don't have the or equal to, and less than also tells me I'm going to shade where my numbers are less, which is down. So a dashed line right here, dash, 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 arrows on the end still because it does go on forever, and I shade down or beneath the line. Right, next one's going to be a little bit easier. It's technically already in y equals mx plus b form, even though there's no b written. I have y is greater than or equal to negative x If there's no B written, that means there's technically a +0 there, but it's already been simplified for you and that +0 is gone. But I'm going to use that as my B. So when I go to move on with this question, I need to state what M and B are. B is just going to be 0 because nothing's being added to the mx. M is the number in front of x, which is a -1. Again, I want it to be a fraction, so I put it over 1. So I start on my y-axis at 0, and then I need to rise a -1, so down 1, and I always run right. There's a lot of points that go with this. Just be careful. Down 1, right 1, down 1, right 1. And then when I can't do that anymore, I do the complete opposite, up 1, left 1. Again, don't connect it until you look at your sign. Okay, this one is a greater than or equal to. Because it has that or equal to, that tells me I'm going to connect it with a solid line. So I go through all my points with a solid line, and I put arrowheads at the end. And then because it's greater than, I'm going to shade where numbers are greater, which is up. So towards the top of the graph. And a super important concept here is where your solutions actually fall. So in the last question for 216, your solution was right here where the 2 points intersected. The reason that is because that is the only point those two lines have common in their solution sets. And every single point on the red line is a solution. Every single point on the blue line is a solution to each individual equation, but only the point that they have in common is what they share. Notice for equations we use solid lines because the solid lines show you all the points on that line are part of the solution. When I look at 217, the red line is dashed. If you remember what that means, it means it only has solutions where it is less than that, because this inequality symbol for the red graph was a less than. That tells me the or equal to is not there. All those points that are equal to that line or on that line are not included. No points on a dashed line are included in the solution. The solid line, however, this blue one, every single point you see on that blue line is part of the blue line's solution. So where do they share solutions? That'll take me to this question for part B. It says, is -4,4 a solution? When I go to -4,4, it's this point right here that I'm coloring over in green. Notice that is where the two lines intersect, which normally you would think yes, but the answer is no. No, it is not a solution. Your explanation is going to be because of what we just talked about, because it falls on a dashed line. None of the points on a dashed line are considered solutions. So -4,4 being on a dashed line makes it not a solution. Okay, talking a little bit further about solutions, part C, how many solutions are there to this system of inequalities? Well, you need to know where the solutions fall for that. Every single point in the double shading is going to be a solution to the system. Remember, system means two or both of them. They only have something in common right here in this double shaded area. And remember, it does go on past the grid. Even though your grid ends, your solutions continue on. So all the points in where I'm really having fun coloring in green right here are the solutions to the system. How many solutions is that? Infinite solutions. There are infinite solutions in that little tiny triangle alone, but there's even more when I extend it past the grid. Okay, infinite solutions. So then part D, name one possible solution. You just have to pick a point, any point in the double shading. I'm going to pick this point right here, 8, 0. Again, there's infinitely many answers. Just pick a point in the double shading. Some people get carried away and think infinite solutions means all solutions. They are very, 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 very different things. Every solution doesn't work, but there are infinitely many solutions in that double shading. You can't pick a point that's not in the double shading. It has to fall in that double shading. All right, let's move on to the last page. All right, so 218, solve the following system of equations. So we're back to equal signs again, and we're doing it algebraically. Okay, so for algebraically, I told you guys during class, you're going to focus on elimination. Okay, but elimination is clarified in the setup. So for elimination, your setup needs to be that your variables lie on top of each other. So x is over x, y is over y, equals, number. Notice how everything is lined up perfectly because for elimination, you're ultimately going to be adding your two equations together. Now, when you add your two equations together, you want something to eliminate. That's the whole idea of the elimination method. Now, there's two different ways to start this problem off, and I'm going to show you both of them. So I'm trying to eliminate one of my variables when I add the two equations together. Right now, if I add them together, I'm going to get 2 plus 8x, which is 10x, and 3y plus 4y, which is 7y. Nothing cancels. So you need to ask yourself if you can easily turn one of your x terms into the opposite of the other one to make them cancel. So what I mean by that is I've got a bigger number of 8. Can I multiply 2 by something to turn it into a negative 8 and make those 8's cancel? The answer is yes. I can multiply the top equation by a negative 4. It'll turn that 2x into a negative 8x and make it all cancel out. So I'm going to follow through with that way first, and then I'll show you with the shortcut if you prefer that instead. So the negative 4 needs to be distributed through. Negative 4 times 2x is a negative 8x. Negative 4 times 3y is a negative 12y, and negative 4 times 6 is a negative 24, and I'm just going to bring down that second equation because I haven't done anything to it. I did not need to. Now that I've finished my setup, I'm going to add the two equations together. Negative 8x plus 8x, eliminate, which was my goal. Negative 12y plus 4y is a negative 8y. My equal sign comes down when I add my two equations together, and negative 24 plus a negative 8 is negative 32. That is a lot easier to solve. To get y by itself, I just divide both sides by negative 8, and I get that y is equal to negative 32 divided by negative 8 is a positive 4. Okay, that's one way to find y. Another way, and you don't need to do both by any means. This is a big, big, big one or the other kind of situation. This is the shortcut. So if you prefer the shortcut that we talked about in class, or you didn't like what I was just explaining to you, give this a try. So I'm going to start by just rewriting the question real quick. If you're using the shortcut instead, you probably don't have to rewrite it. You're just going to do this to start. Okay, but this is the other way. So your shortcut is the same setup every time. The second you have to solve a system of equations algebraically with elimination, you put parentheses around the whole top equation and the whole bottom equation. You take this number, which is an 8, you put it on top. You take this number, which is a 2, you put it on the bottom, and you make one of them negative. It does not matter which one you decide to make negative, as long as one of them is negative. Either way, it's going to make something cancel out. It's just a lot of distributing. So I'm going to distribute these two numbers through to all of their three terms. And here's what I get. So negative 8 times 2x is going to be a negative 16x. Negative 8 times a positive 3y is negative 24y. And negative 8 times a positive 6 is a negative 48. So notice the numbers are a little bit bigger, but it takes that extra thinking step off the first initial start by using the shortcut. Okay, now I'm at 2 times 8, which is a positive 16x. 2 times 4y is a plus 8y. And 2 times negative 8 at the end there is a negative 16. Make sure you multiply through to these numbers at the end. If you don't, you will end up getting the question wrong and your numbers are going to be all wonky. You should get nice numbers for questions like these. Okay, so just like I did before, I'm going to add the two equations together, and I notice that my x eliminates again. So negative 24y plus 8y is a negative 16y. My equal sign comes down, and negative 48 plus a negative 16 is a negative 64. Again, a heck of a lot easier than it originally looked. I'm good to start solving for y now. I divide both sides by that negative 16 to get y by itself, and I get y equals 4. So notice, either way, you end up with y equals 4. It's just up to you whether you want to do that extra thinking step up here to start off the problem, or you don't want to think so much in the beginning, you use the shortcut, but you end up with bigger numbers that can be plugged into your calculator anyway. So it's entirely up to you what you choose to use for that first step. Now I say first step because we're not done. When you're solving a system, remember your answer needs to look like a point, x, comma, y, which means you need to solve for x and you need to solve for y. So far we've only solved for y. So whichever method you choose to do for solving for y is up to you, but you need to do this additional step. So to find my missing x value, I just take what I found y to be, which is 4, and I plug it into either of these two original equations. Try to pick the easier of the two, like the most positive one or the one with the smaller numbers, just to help yourself out. You can plug it into both of them to make sure you are right. You should get the same answer for both, but it's completely up to you. So I'm going to take that y value of 4 and plug it in where I see a y in the equation that I chose. So I'm going to bring down the 2x plus 3, and then in place of y, plug in a 4, and the equals 6 comes down. Okay, simplifying this a little bit further, the 2x comes down, 3 times 4 is 12, and the equals 6 comes down. Here's that basic form for solving an equation. We keep going back to this, so really make sure you know how to solve from here. Get rid of what's being added or subtracted first, so get rid of that plus 12 by subtracting 12 from both sides, and I get 2x is equal to negative 6. Get rid of that 2 with the x by dividing both sides by 2, and I get that x is equal to negative 3. So my final answer, my final solution as x comma y is going to be negative 3 comma 4. What that tells me is that if I were to solve this exact same system graphically, it would end up crossing or intersecting at the coordinate point negative 3, 4 on the grid. All right, let's practice that elimination again. Okay. So this one, I am going to use the shortcut to start, and you'll notice that the shortcut or the other way would work. It's going to end up getting you the same thing. So for the shortcut, I have to use elimination. I put parentheses around both of my equations. This number goes down here. This number, which is a 1, even though it's not written there, there's an imaginary 1 in front of that x, goes up there on the top. And I have to make one of them negative. For this one, I'm going to make the bottom negative, only because that top number being a 1, if I distribute 1 through to the 3x, the y, and the 13, it's not going to change anything. So what I could have done instead, and what I'm going to try and show you if you choose to not do the shortcut method, or even if you want to just try to learn this other method, entirely up to you. Whoops, I just threw my pen. Oh, sorry about that. What did I just? Okay, so if I had a 1 on the top, it wouldn't change a thing. My top equation would just stay 3x plus y is equal to 13. What you could have looked at this instead is I have a 3 in front of my x. I have a 1 in front of my other x. I know that a positive 3 and a negative 3 would cancel each other out. So if I just multiply this second equation by a negative 3, it'll end up making a positive 3 and a negative 3, and they'll ultimately end up canceling. Whether you use the shortcut or not for this one, you will end up getting the same setup. So again, if you distribute that 1 through, it's just going to stay 3x plus y equals 13. On the bottom, distribute a negative 3 through. Make sure you carry that sign all the way through. Negative 3 times 1x is a negative 3x. Negative 3 times 6y is a negative 18y. Your equal sign comes down, and negative 3 times negative 7 is a positive 21. Now that I've taken care of my setup, I'm good to start eliminating. 3x plus negative 3x eliminates like I wanted it to. A positive y minus 18y is going to be a negative 17y, and 13 plus 21 is a positive 34. Okay. Again, this is a heck of a lot easier than those original two equations. So to get rid of that negative 17 that's being multiplied to y, I just divide both sides by negative 17, and I get that y is equal to negative 2. I'm only halfway done, but I have done, I think, the harder part of the problem. I now need to find x. Again, it does not matter which equation you use to solve for x. I'm going to go ahead and use the top one. If you use the bottom one, you will get the exact same answer. Something you might want to do is plug in negative 2 for y into both of them and make sure you get the same x value. That would be a good way of checking your work. It's completely up to you. Okay, so I am plugging in this negative 2 in place of y. So 3x instead of plus y, I'm going to write minus 2, and the equals 13 comes down. To get x by itself, this is that basic form. I get rid of what's being added or subtracted first. So I undo minus 2 by adding 2 to both sides, and I get that 3x is equal to 15. Get rid of that times 3 by dividing both sides by 3, and I get x is equal to 5. So I have an x value, I have a y value. My final solution is going to be 5, negative 2. Again, what that tells me about graphically is if I were to get both of those two original equations into y equals mx plus b form and graph them on an x and y axis, they would intersect at the point 5, negative 2. All right, last question. It says, Jacob and Zachary go to the movie theater and purchase refreshments for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. Zachary spends a total of $27.50 for 4 bags of popcorn and 2 drinks. It tells you, let x equal the price of popcorn and y equal the price of a drink. So we need to remember that for sure. It says, write a system of equations that can be used to find the price of 1 bag of popcorn, or x, and the price of 1 drink, which is y. Okay, so I have to write a system, big word there to remember that it means 2. So basically write 2 equations that can be used to find x and y is what it's asking me to do. And then it's so nice down here, you do not need to solve. So we just need to write out 2 equations, and we've finished our review packet. So I'm going to start with Jacob. Okay, this is a lot like the the brownies and cupcakes question that we did in the notes. So I'm going to go sentence by sentence, starting right here. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. So bags of popcorn is x, and he bought 2 of them. So that means I'm going to write 2x. He also bought, in addition to that, so plus 3 drinks, 3y. When he bought the 2 bags of popcorn and the 3 drinks, he spent a total, which means equals, of $18.25. That's my first equation in the system. My next equation is going to be for Zachary. So Zachary, if I read that sentence, spends a total of $27.50 for 4 bags of popcorn and 2 drinks. Must have been very, very hungry. Okay, so 4 bags of popcorn is going to be 4x, because again, x is the price for a bag of popcorn, plus 2 drinks is going to be 2y, and his total amount spent was equal to $27.50. So notice, if I did have to solve this, my variables are lined up: x over x, y over y, equals over equals, number over number. So I'd be ready for elimination if I did want to solve, but I do not need to solve this one. Okay, so I really hope that this video was helpful for you guys. If you do have questions, please come to the optional review class. If you have any other questions, please feel free to email me. Go back in the video and watch over the questions that you needed more help with. But best of luck studying, and good luck on your test.